We're from Micas Networks, and we're going to talk about one of our specific products that we have been demoing out here in our booth, and then we'll talk a little bit more about who we are. So Tim Lin's going to kick that off for us.
Hi, good morning, everyone. So today we're going to introduce our next generation network switch, which is the by using the Tomahawk 51.2 terabits per second CPO switch. So as you see here, we're introducing the 51.2T switch. Basically, has two big components. One is the sub-chassis module. The second one is the switch control module, which called SCM. Will be mentioned that later. So the system using the Belly 51T switch, co-packaged switch. And overall, the faceplate port has 128 by 400 FR4 optics port. Connector is LC type connectors. It has 16 RLM remote laser module, and the dimension of the box is 4RU size. It can support the Sonic and other open network operation systems. Pretty much the highlight point for this box is the low power consumptions. It's roughly about 1,300 watts for the system. So for furthermore information about the powers, the breakdown is like the OE optical engine takes around 25 to 30 watts. The RLM laser module is around 8 to 10 watts. And the ASIC itself is around 600 watts by typical operation case. And compared with the traditional pluggable system, we are seeing that it's roughly about 30% reduce of the power. So this is the faceplate or front view of the system. As you see here, we have 128 by 400 FR LC duplex connector in the front. We have a dedicated design for the power PSU air channels. And so also we have, just like the typical switch, it has the console port, has the management port, and also we have reserved a USB port to support the OCP debug module. It is the rear view of the system. The system using 8 fans and has redundancy, so it's 7 plus 1. And also the power module PSU is 1 plus 1. We select a 3,000 watts PSU for these systems. So during the design, we have 3 major considerations for this next generation network switch. The first one is the stability of the optical path. The second one is the thermal concern. And the third one is the complexity of the production and the assembly. So talk about the stability of the optical path. How to reduce the disturbance of the optical fiber due to the cooling airflow in the system is the main concern here. And the second one regarding the thermal, because now used to be the transceiver in the front has the best cooling airflow from the inlet. Now become all the optical engine are located in the center around this ASIC. So all the heating components are in the center of the box, create the challenge for cooling out those components. The third one is because the CPO has a lot of fiber routings inside the system. So how to increase the productivity, production capacity and efficiency becomes another challenge or another concern for design and manufacture this box. So let's look at the first one regarding the optical path. So the way we do is we have an onboard fiber tray which can accommodate extra fiber length and reduce the skew of the optical fiber caused by different fiber path. So all the fiber will well settle and routed inside the fiber tray, and which can reduce the vibration of the upper optical fiber. And the right side, as you see, that is how it being assembled. We have a fiber box module, we have an onboard fiber tray, and the 51T Tomahawk 5 and the belly CPO modules, and the base tray and the other components. We also do the customized fiber kit, which we mentioned that in the previous slide. The fiber kit divided into two parts, fiber box and the simplified fiber kit. By using the micro LC connectors in the fiber box, there's enough space for replacing the MPO connector or other high-density connector. So in this fiber kit design, overall, we only have 3 connectors. One is the FAU fiber array units connector, and the MPO connector, and the RLM connectors. By this design, we can significantly reduce the fiber length, also increase the productivities, because everything are being divided into small modules and well done before the final assembly. The other one is about the thermal design we had for this box. So as you hear, we mentioned earlier, we have a dedicated inlet for the PSU, and we utilize as much as the front faceplate for the air inlet. So also for the fan design, we use dual router, and a shutter is added to the inside of the fan, which can avoid the airflow come into system from the fan outlet set, which is the reverse airflow. In any case, the fail. Here's another highlight point for the thermal design. So for this CPO-based system, we're using the different heatsink compared with the traditional pluggable system, which also does the design, the Tomahawk 5. So as you see here, the CPO heatsink, which has less airflow, only 152 CFM, compared with the traditional one has the 226 CFM. But by the new design of the heatsink, we can get roughly the similar thermal resistance, about 0.08 degrees C per watt. Also for the RLM design, we does the design ups and down, which reserves the space for the RLM heatsink. That can also reduce the fiber vibration caused by the RLM heatsink airflow and improve the stability of the optical system. And the RLM and the optical fiber box we mentioned earlier on the top of the RLM and the cage, that all be standardized module and can disperse the difficulty of the system assembly. So let's talk about the CPO manufacturing challenge. So because a lot of fibers and the FRs signals fibers are routing inside the box. So the requirement of the manufacturer become very challenge. What we do is we have a dust prevention room and a workbench. The workbench is 1K class, and the clean room is 10K class. Also, during the process, we do need to use the microscopic exam interface to check the interface of the connectors. And we also implement the fixture for the FAU installation and calibrations. And at the last stage, we need to do the active test to test the laser power consumptions, the laser power grade. So also for the productivity part, we use the color coding system for different fiber, and to identify the fibers and do the installation. So pretty much that is the main content I want to bring to here and introduce to everyone. And also we have a couple call actions we plan to do in the next. So we are trying to work with our partners to bring the optical fiber kit and connector to have multi-source and multi-supply. And that can build out the ecosystem. And also, in the next step, we are looking at this new technology. We'll be moving to for the 200 gig SerDes architect, and also the liquid cooling, because the parts getting hotter and hotter. The cold plate liquid cooling could be implemented in this or next generation of the CPO system design. And by doing that, because we remove the high power consumption, it can also reduce more power consumption for the systems. So here, I hand over Sean for the next couple slides.
Thanks, Tim. I'm Sean Rasmussen. I'm the Strategic Planning Director at Micas Networks. It's cool that we have this product. If you haven't had a chance to see it in our demo, please come by. It's been really busy there. Another cool thing is when you put up a slide, block diagram, all the cameras that came out that I just saw. I think that means we're doing something cool, and I'm excited about that. So thank you, and please take a few minutes to stop by and see this very cool design. Wanted to talk a little bit about Micas, because that's the first question I've gotten here is, tell me about the CPO modules, what you've got there, to give me all the lowdown of where the status of that product is. The second one is, who is Micas? I don't know who you guys are, and I love answering that question. So come by the booth, and we'll give you a full-blown. I've got just a couple minutes, so I'm going to tell you a little bit about us. But here's our portfolio. You see, we've got our CPO that Tim just talked about right there, shaded in the box. But that's not all we do. So we've got a lot of joint development projects that we're working with our key partners, but we also have switches on the shelf right now that you can come hand me a PO and I would ship you a box right away. So we are here today, so we're excited about that piece. So broad portfolio, Tomahawk 5, Tomahawk 4, Tomahawk 3. We've got Jericho, we've got Trident. We've got a broad portfolio, 1U to 4U. We believe we've got the right hardware. So as we're starting up, that is one of the first key components that we bring to the table, is a strong portfolio. Second, we believe in Sonic. We absolutely believe Sonic is the wave that we are riding. We are a white box switch company. We've tied ourselves to Sonic. We believe that's absolutely going to be the win for us as we've come into the market. So, right hardware, we believe we've got the right NOS. Then what's the next piece you need? If you're thinking about putting the puzzles together as a new startup, what else are you going to need? You're going to need the support. You're going to need the service. You're going to need all of the mechanics of making sure your supply chain's healthy. All of those pieces, we've worked really hard over the last year to make sure we have those pieces in place as well. So we're excited about that. We've got we believe premier service, right from pre-development, pre-deployment, right up to customer service to as long as you are deployed, as long as you are going into production. We're excited about that. So white glove service is a key part of that. You put all of these components in this circle together, that's why we believe we're going to be successful as Micas, and we're very excited about that. We've had a lot of activity in our booth. Please stop by. Come in. If you haven't had a chance to meet us yet, come on in, talk to us. All of our executives are there. You'll be able to meet the whole team. Thank you very much, and have a great last day of the show.
Thank you for the presentation. We have a couple minutes for questions. Please line up. Yeah, thank you.
Hello. So I work for Arista Networks. So by the way, very nice presentation. It's very impressive. I watched your demo. So congratulations.
Thank you.
I have a question on the production side. So have you thought about what are the procedures to try to diagnose any link issues? And then if there is a few interfaces that happen to have issues, or what is your model? Are you going to take back the box? Have you thought through those aspects, because all of us will have to deal with that? So
Yeah. So this box we're working on right now, as you see, we're trying to do the a modular design. I like the fiber box or like the subsystem. So by doing this kind of case, if have a infield failure, customer or us, the field engineer can help to pull out the box and do the simple swapping to fix that immediately, right? And regarding the diagnostic things, like what I mentioned earlier, we are going to use in the microscopy and to check all the fibers are clean and before ready to ship. So things are being established. For example, like a FR assembly, we also have a fixture to make sure that every process is robust and solid before we can deliver the product.
Great question. Thank you.
I think we have one more question we can probably take.
Thank you for your presentation. I got one question on your FAU, the fiber array unit. I assume the fiber come out of RLM is the PMF fiber. It seems that within that FAU, you mix the PMF with the regular fiber together. Do you have any talk about how do you maintain the polarization fiber throughout?
Oh, this one, for this part, I don't have an answer right now, because this is more like the manufacturing process and the part selections. But as you see, the FAU actually combined two parts. One is from the optical engine, and one is for the LC connector. One is light source, one is outgoing. And yeah, it's been well supplied and designed from our source. So at this moment, I think it's robust. Furthermore, answer I need to dig out. We can exchange info, and you can follow up with me regarding that. Okay?
Thank you. Great question. Thank you, guys.
Thank you.